Okay, today we are going to start paper 2 of our IGCSE Computer Science, and we have successfully covered our 4 chapters from paper number 1, Computer Systems, right? It means that more than half paper 1 is completed. And now we are going to jump to the paper number 2, Algorithms, Programming, and Logic. Chapter number 7 is about algorithms, design, and problem solving.
Problem solving. Okay.
So this is our chapter number 7. Whenever we are going to plan any program, we are going to make any program, we are going to develop any software, there are some stages. That stages are mandatory to implement in our programs.
Programs. Okay.
Why? What is the reason? Because if you are going to make any system, any program, any software, and you're dividing it into a phases, it will be very easy for you to complete it on time, to understand it better. So if you're breaking down any problem into several steps, this is a very good programming technique. So a topic is program development life cycle. In this topic, we are going to divide our program into 5 stages. How many?
5 stages.
5 stages. The stages are as below: analysis, design, coding, testing, and maintenance. So these 4 steps are going to be performed by the user to complete their task. The first one is analysis, again design, coding, testing, and 5th one is maintenance. It's not mentioned, but I'm just writing it, maintenance. Okay. So let's start from the analysis. What do you mean by analysis? Any idea?
To analyze something.
Analysis means to think about your objective, to collect information about your objective, to make a report about your objective, that what you are actually going to do. So if you are going to do a research of your task, it will be very, very easy to perform your task. So analysis means that you are going to understand, you are going to think about the solution, and you are going to think about the requirement, what you need to complete your program. That's called system requirement.
System requirement. Okay.
Right? This is very important thing in analysis. You can say fact finding. This is very important from an analysis. Right?
Right.
So these are some stages in analysis in which the user is going to understand what is the software, what is the solution of the software, how software works. In this stage, you're also going to collect the data. So that's called data collection. Right? That's called?
Right. Data collection.
Writing it here. Or you can say program specification. So these terms are used in our analysis stage. So what do you come to know about analysis? Tell me.
Analysis is something which we can think and which works on solutions.
Yes. In which we are going to collect the data as well about the software, what we are looking for. We are going to collect the data. We are going to collect the facts on which we are going to perform. Like, let's suppose if I'm going to assign you a software that you have to make a software on a rent a car system. What? Rent a car.
Rent a car system.
So what is the first thing you are going to perform? You first think that what is rent a car? How I make a software? How I'm going to collect the data? What will be my services? How to provide the services? These are some questions. These answers are called fact finding, data collection, program specification, like that. System requirement. Are you getting it?
Yes.
So look, this is called requirement specification. They are called it requirement specification. I call it system requirement, right? So both are same.
Right.
The analysis stage is going to divide into two steps, abstraction and decomposition. What? Abstraction and decomposition, right? So what do you mean by abstraction? Let me tell you. Abstraction keeps the key elements required for the solution to the problem and discards any unnecessary details and information that is not required. In simple wording, abstraction means to delete unnecessary data from your software. How? Let me teach you. Did you see these two maps?
Yes.
Which one is easier to understand?
The second one.
The right-hand side. What do you think about the left hand?
It's too detailed and then
Exactly. So this is my abstraction topic. This is a map in which there is no trees, there is no rivers, there is no further maps, points, blah, blah, blah. But on the left-hand side, you can see a lot of things. We don't want these things. We make the program simple and easy to understand. This is called abstraction.
Okay.
Any confusion?
No.
Now, the next step is decomposition. In decomposition, you are going to break down a complex problem into a simple or smaller parts. So there is a big problem and you're going to divide it into a smaller parts, which can be further subdivided into more smaller parts. So I have sent you notes. Let me show you my notes. You can see in these notes, you can see a chart here for analysis, design, coding, and testing. And in this analysis, look, I have teach you in detail about the system requirements, right?
Right.
Okay, so in abstraction and decomposition, let me show you something. Yes, look, this is a chart. In this chart, you can see you are breaking down. You're breaking down a problem into a steps. This is called your decomposition.
Decomposition.
Right?
Right.
Let me clear these all for you so it will be more easy to understand. Just a second. Yes, I think now you are able to understand what's going on here. So decomposition means the breaking down a problem into a sub-problems. So you see here, I'm using my red marker. This is a system, right?
Right.
And you can see I'm breaking down or decomposing the system into the topic 1.1, 1.2. No, not like that. Let me tell you in other way. Just a second. I think the other way is much smarter. Okay. This is topic 1. This is topic 2, 3, and 4. Now you can see I break the topic 1.1 and 1.2. I'm breaking down the topic 2.1 and 2.2. I'm breaking down my software into the stages 3.1 and 3.2. So look, these are the subsystem. Again, I'm breaking down it into further 1.1, 1.2. So these are again subsystems. So you can see 4.1 and 4.2. So further 4.1 is divided into 4.1.1. Look. And this is 4.2.2. What do you think now? So in this way, you are going to break the problem into the smaller step called, come on, subsystems. And further, I'm going to divide the subsystems into, again, subsystems. So this is called your decomposition. Not only decomposition, you can call it as a structure diagram, or as a top-down design, or as a stepwise requirement, or as a subsystem. So there are multiple names of this topic, not only decomposition. Decomposition. How many names are there? 5.
5.
What are they?
Subsystems.
Yeah.
Structure diagram.
Top-down design.
Stepwise refinement, top-down design.
Yes. I think I understand it. Great. So this is how you are going to write it or understand it. So what I teach you up till now, I teach you about the stages of the programming. You have to write down the stages name first. Then you need to write down about analysis. And after analysis, you need to define the types of steps of analysis. What are steps? Abstraction and decomposition. You have to draw the diagrams. Is that okay?
Okay.
Start your work now. I'm just moving you there, right here. Okay. So the program specification from the analysis stage is used to show how the program or problem should be developed. Because after finishing the analysis, you come to know that the next stage is there to represent that how you are going to develop a program. When the design stage is complete, the programmer should know what is to be done, all the tasks that need to be completed, how each task is to be performed, and how the tasks work together. In all these stages, analysis is the most time-taken stage. And in analysis, you need to collect and do a lot of effort and work. After collecting all this information, there is a design phase. In design phase, you are going to design the layout of the program, the outlook of the program. And in design phase, you come to know what you are going to do, how the things are going to be performed, how the things are worked together. So all these things can be documented formally by using structure charts, flow charts, and pseudocodes. Right? So these are the 3 things you have to do. What they are, tell me again.
The structure part, flow chart, and
pseudocodes, right? So these are the mandatory points in the design phase.
Okay.
After the designing, we have a topic of coding, right? So after you're going to design the outlook of the program, the things, the flow chart, the pseudocodes, now you have to code your program. It means now you need to start writing your program, and that's called coding, right? So
Right.
this is sometimes known as an implementation stage. Yes, a very good wording here. Implementation stage. The programmers work on the design modules such as input, output, and process, and write the code to make each part of the program functional. We have done analysis and design, and in both stages, we are going to collect and design the collected information in a particular manner. But coding is the most important part because now you're going to physically implementing all the details which you have been observed in design and in analysis. And you are going to write down the solution of the program, right?
Right.
So the programming is then linked together to complete as a solution. So now you're going to write down the code, linking together, and then a complete solution will be produced. But there is a testing strategy. It's planned by the analyst, and the test plan will compromise details of all the programs to be tested. Yes, you know what is testing. Testing means to check your thing, the program, whatever you have made. Without testing, you cannot circulate your program to anybody. You cannot do that. Even, iPhone, Samsung, if they are going to launch their mobile phones, they are not going to launch their mobile phones in the market directly. First, they are going to test their mobile phones, new models, 3 months, 4 months, 5 months. Give the testing sets to their employees, and the employees are going to use them at their homes for 6 months, 4 months, 3 months. And once they are going to pass, yes, it's okay, it's perfectly fine, it's working very well. Then the mobile phones will be launched in the market. It is not like that iPhone, Samsung makes the mobile launch in the market. No, there is a testing phase. So it is very important. Testing every part of the programming requires a test strategy. Yes, of course, if you're going to test the things, the program, there must be a proper test strategy. First, the entire system is divided into small sections that are tested for input, output, and validation rules. Yes, validation and verification will be discussed in great detail in this chapter later. But
Okay.
for the program testing, you have to make a small sections, then you need to input the data, you need to process the data, you need to validate the data according to the rules. So the test data is used for all of the tests to be carried out. So there's a special data called test data. So testing each part of the code individually is known as a unit testing, and integration testing is used when the code is all combined to form a program. So if you're going to test each part of the program, that is called unit testing. And once you're going to test the unit testing, there is an integration testing as well, in which the code is combined to the program or other part of the code. Integrate means to combine two things, right?
Right.
So once you're going to test them, there is an error reports, the errors, the bugs are there, and you have to fix the bugs. Then you need to test the program again. And you need to test it again and again until your programs becomes error-free. Right?
Right. Right.
So now you have to write down, now you need to do what? You have to, did you draw this decomposition chart?
No.
You have to
Yes.
draw this decomposition chart. You need to write down the names of this decomposition. Then let me know. I will drag you to the design phase. नहीं बल्कि ऐसे कर लेते look. Is that better? You have to write down the heading of decomposition, structure diagram, stepwise. All the headings are there. Look. And then you need to draw this. And then you have to write down about design phase. Quick, please. So if you're going to conclude our all stages of program development life cycle, so what we have learned? We have learned about analysis, we have learned about design, coding, testing, and maintenance, but it is not the part of the syllabus. But I will teach you this in a very slight way. So in analysis, what we learned that there are two things. Process of investigation. Yes, this is a good word, investigation. I think this word should have been used by me. Investigation. Like you're going to fact find the things. And there is abstraction and decomposition as well. In the design phase, you're going to use structure charts, flow charts, and pseudocodes, right? In the coding, you need to use an iterative testing and writing the program. And then you need to test your program completely in a manner so you're going to explore whether it works under all conditions or not. Maintenance means you're going to update your program every time by some new tools and replacing some old things. That's called maintenance, like you using Android. So Android is going to be maintained within an year. The new version comes after the older version. That's called maintenance, that you're launching something new for the users. Is that okay?
Okay.
So this is a summary, right?
Okay.
Now we are going to start the topic of computer systems. All computer systems that operate are made up of subsystems. We have already done about the subsystems. In the diagram above, there are the subsystems. Remember, I teach you about the subsystems. That subsystem is a decomposition of a computer problem into smaller steps. Remember up there? So which have
Yes.
other subsystems within them. These are the small processes that are vital for the bigger system. They are talking about this topic. I think you're not getting it.
Yeah, I mean, revision is required. I can't just get it in one
This one,
time.
talking about this one. This
Yes.
is subsystems, right?
Okay, so what I think is happening is this is a diagram. First of all, it starts from the system.
Yeah.
Then the designs go from the top down, which is the 1, 2, 3, 4 row.
Oh, you can
And the
say
subsystem
breaking down of a
breaks
problem.
down,
Yeah.
decomposing.
This is the good wording, right? So we are
Yeah.
here with the same thing, that while you're going to design any computer system, you always work with the subsystems, right? And then breaking
Correct.
down that subsystems into further subsystems. So the big problem will be smaller, right?
Small.
Each problem to be solved by a program can be decomposed into its own component parts, right? So programmer can employ a combination of different methods to plan the solutions to the problem. So it means that after the decomposing the problem into the subsystems, now the programmer is going to sort out the methods in which the problem can be solved easily. So there are some methods. Pseudocodes, structure diagrams, flowchart are often used in combination to design these solutions. So the first thing is a flowchart. Do you know what do you mean the flowchart?
Flow chart is like order and order, like sequential order.
Basically,
Basically, a diagram.
flowchart is a pictorial. Yes, good wording. Flowchart is the pictorial representation of your program. What is flowchart? Flowchart is a, let me write down the definition just a second. You can see flowchart is a pictorial representation of your program.
Okay.
So I'm going to write it down. Flowchart is the pictorial representation